Incompressible Bernoulli. A horizontal pipe 1 foot in diameter tapers gradually to 8 inch in diameter. If the flow is 500 cubic feet of water per minute, what is the difference between the pressures at the two sections? The answer we get is P sub A minus P sub B is equals to 443.63 pound per square foot. Now, the first section, we get 1 foot in diameter. Next section is 8 inches in diameter. This is number 1. This is number 2. Now we know from M equals rho AV, or Q is equals to AV. Now we also know that Q1 is equals to Q2. And from the given, we have diameter 1, which is equals to 1 foot, 1 foot, and diameter 2, which is 8 inches. However, knowing that 1 foot is equals to 12 inches, this is 2 by 3 foot. The other given that we have is the Q, which is 500 cubic foot. 500 cubic foot. Now to get the answer PA minus PB, we have to use incompressible. However, we also have to use this to get the velocity 1 and velocity 2. The incompressible Bernoulli is equals to P1 plus 1 half rho V1 squared is equals to P2 plus 1 half rho V2 squared. Next, we got to get the V. We have Q is equals to A1 V1 Q1. Now again, Q1 is equals to Q2. So the 500 cubic foot is equals to the Q2. 500 cubic foot is equals to A1 V1. Now to get V1, we divide A1. A1. A1 is 1 foot in diameter. 1 foot in diameter. And the formula for a cylinder is pi d squared over 4. So 500 foot cube over pi 1 foot squared over 4. And this is equal to V1. V1 is equals to calculator 500 over pi times 1 squared over 4. We get a velocity 1 of 639.619 foot per minute. Let me check that. If the flow, yep, per minute. This is per minute because 500 cubic foot of water per minute. Per minute. Now for V2, we use Q2 is equals to A2 V2. Doing the same over A2 over A2. Divide. We have Q2 of 500 foot cube per minute minute. Area number 2 is 2 by 3. So pi 2 by 3 foot squared over 4. Calculating that, we get 2 over 3 squared. We get 1432.39 foot per minute. This boat is 2 decimal places. Now we need to turn it to feet per second, so 632 divided by 60, and 1432.39 divided by 60 is equals to 639.62 divided by 60. We get 10.66 foot per second. As for the velocity to 1432.39 divided by 60, we get 23.87 foot per second. Now we have V1, which is 10.66 foot per second, and we have V2, which is 23.87 foot per second. Now that we have both the velocities required, we can then use the original substandard Bernoulli's equation. We have P1 plus rho V V1 squared, 1/2 rho V1 squared equals P2 plus 1/2 rho V2 squared. Now simply subtract P2. We get P1 minus P2 plus 1/2 rho V squared or V1 squared is equals to 1/2 rho V2 squared. This is 1. Now again, simply subtract this part. We get P1 minus P2 is equals to 1/2 rho V2 squared minus 1/2 rho V1 squared. And we can further simplify this as rho squared is equals to V2 squared minus V1 squared, which is equals to P1 minus P2, which is the pressure differential that we need. Again, by algebra, we can simplify both of this because this and this is a constant, this and this is a constant. Now, since this is an English system, our density will be 0.0023 2377 slug per cubic foot. That's for air. However, this is for water. This is density of air. But for density of water, the constant is 62.4 pound per foot cube. Okay. So technically we don't use the slug constant. Okay. So given that P1 minus P2 is equals to rho squared, V2 is 23.87 7 foot per second squared minus 10.66 foot per second squared. Rho is 64 62 62.4 pound per foot cube over 2 to 3.87 foot per second squared minus 10.66 foot per second squared is equals to P1 minus P2. Now calculating P1 minus P2, we get 23.87 squared minus 10.66 squared 2.423.87 squared over 2 62.4 10.67 squared. Okay, my bad. So we don't use this pound per foot cube, we use the slug one. So our raw for water is, let me search that up, density water, English slug 1.94 1.94 slug per cubic foot. So 1.94 slug foot cube is equals to over 23.87 foot per second squared minus 10.66 foot per second squared. Okay, and this is equals to the pressure difference P1 minus P2. Now calculating, we get 1.94 over 2. After getting all that, we get 442.457. Now with two decimal places, we get 442.46 pounds per square foot. Pound per square foot. Double checking. 44.63 and we get 442.46 and 443.63. Why? Any difference? 1.937. Density. Checking with the constant. Light deviation. Anong ron yan? Yeah, that's the general gist of it. There's slight deviation from the density of water, especially in this part. Though, use the slug per foot cube. I personally used 1.94. But for this question, but for this question, I guess they used a higher slug value. So they got that. They got this 443.63 comparatively to the 442.46. But all in all, that's how you get this answer. Lo, baliw.